Okay, here we go. We're talking about 6.3 today. 6.3 has to do with parametric equations. Parametric equations introduces the variable t. Now, in your book, they use a lowercase t. Works either way. We're going to be able to take our shapes, what we're used to putting in our coordinate plane, and change them into parametric. All right, so the first thing I want to start with is, if you are given, let's start with this, example number 1. Let's say you are given 2 equations. Make them really easy. Let's say I have x equals t plus 3 and y equals 2t. Okay? What we want to do is actually put these together into our coordinate plane, right? Kind of like what we just did on our calculator. The calculator went ahead and put them together. We're going to do it here. So what I want you to do is to go ahead and make yourself a table. I'm going to go, yeah, let's go this way. You guys like it if I go vertically, right? You prefer that way? Okay. So we're actually going to need 3 different things in our table. The first one in our table is going to be our t. Second one in our table is our x, and the third in our table is y. So if we start by saying t is -2, if I plug -2 in for t, what do I get for my x coordinate? Awesome. If I plug -2 into my y equation, what do I get for my y coordinate? Good. All right. So now let's do -1. Plugging -1 into this beautiful equation, our x value is 2, and our y value is -2. Let's do 0. What is our x coordinate at 0? Good. And our y coordinate at 0? Awesome. Yeah, we're just going to do 2 more. All right, if I plug 1 in here, our x value is 4. And our y value is 2, right? If you put 2 in here, we get 5 and 4. All right, so now we're going to take it from these equations. Let's go ahead and plot these beautiful points we came up with. Our first point is 1, -4. Put a dot. Our next one is 2, -2. 0, 3. Oh, sorry, 3, 0. Better say that right. 3, 0 goes here. 4, 2. Over 4 and up to 2. And 5, 4. It should be a line, which would make sense, right? Because nothing up there is squared. A squared would give us a turn in it, correct? Right? If I had something that was cubed, it would give us 2 turns, which it does not. So it does make a line. Mine's not a very straight line, but it should be. All right? So that's one way to take it from parametric and graph it in our form. Okay? Questions at all? Seems pretty easy? That's really all you have to do for 5 and 6, but I have you doing odds, right? Yeah. So just 5. 5 is similar to this one. All right. Example number 2. So we worked with a graph and trying to change it into our coordinate plane. However, what I'd like you to do is also write the equation for it. So if you are trying to change equations from parametric to, and we're going to be putting it in ours, so to our coordinate, we'll just say coordinate. Okay, so let's say those 2 equations I just had were x equals t plus 3 and y equaled 2t. So the idea is to eliminate t. So what we want to do is in the first one, get t by itself. So subtract 3, right? I have x minus 3 equals t. Then I can take this x minus 3 and plug it into the y equation where t is. So I have y equals 2 times x minus 3. So I'd have y equals 2x minus 6. Go back and look at that graph. Does it look like the graph could be 2x minus 6? If your drawing's better than mine, I hope so, right? I mean, technically it would have been here. It goes up 2 and over 1, so it should be that line. That's how it works. So, what we are going to be doing for 11 through 22 or 21 is you are simply coming up with the equation to replace t. Okay? So you're putting two of them together. So here's another example. Let me show you. Example number 3. Let's make it a little bit harder. So the actual directions are going to ask you too for 11 through 21. The directions say use algebra to eliminate the parametric variable. So let's start off with something as beautiful as x equals t squared and, whoops, and y equals, how about t plus 7. I don't know. So, we want to try and get it y equals, right? Because that's how we write all of our functions. What can I do to get t by itself? Square root it. I agree. We can square root it, right? Square root both sides. If I square root it, I get the square root of x equals t. Now, technically, that should be a plus or minus, right? We're going to leave it as a positive for now, but. So then I'm simply taking the square root of x and plugging it in right there. So I get y equals the square root of x plus 7. Let's do one more that's a little bit harder. What do you think? Just a little bit. You like this level? What if I gave you, I need something a little bit harder. How about x equals 5 minus 3t, and y equals 2 plus t. So this one's a little bit tougher, right? We're trying to get t by itself, so I'm going to first subtract 5, so x minus 5 equals negative 3t. Then what? Good, we're going to divide by negative 3. So we get that t equals x minus 5 over negative 3. We're going to take that and plug it in over here for t. So I have y equals 2 plus, I'm going to put it in parentheses so I have it all together. All right. We can leave it just like that. Totally leave it that way, or we could simplify it further. If you left it like that, I'm totally happy with it. If you want to simplify further, what this is y equals 2. And then this is a negative 3 goes to each piece. So technically it's negative 1/3 x plus 5/3. Then we could collect like terms. So we get y equals negative 1/3 x. 2 plus 5/3 would be 11/3, right? That's fine. I'm okay either way. All right. Probably going to be in the back of the book that looks like this, but again, this is fine. There's no problem with that whatsoever. Yeah. Absolutely. Help yourself. All right. So how are we doing? We're okay with this part? All right. Now I'm going to throw something a little bit tougher at you. Just a little bit. Just a little bit. Example number 4. This is going to help you with 23 and 25. Oof. All right. Again, we want to use algebra to eliminate the parametric. All right, so our first equation could be something that looks like this. X equals 4 cosine t. And y equals 4 sine t. All right, so when you get one like this, let me fix that equals there. The first thing I'm going to ask you to do, step number 1, I'm going to ask you to square everything. All right? So my very first step, I'm going to start over here. I've got x squared equals 16 cosine squared t. Over here, I've got y squared equals 16 sine squared t. Not a bad step, right? Okay. Now, I'm going to ask you to add your left sides and add your right sides. So, step 2, add left and add right. All right, so on the left, I have x squared. Whoops, let me change that. On the left, I have x squared plus y squared equals, whoops, squared. The x squared is 16 cosine squared t, and the y squared is 16 sine squared t. How are we doing? What can I undistribute out of the second side, or the right side? All right, so I have x squared plus y squared equals 16. Leaves me with cosine squared t plus sine squared t. Does that sound familiar? Yes. What does that equal? That equals 1. We are left with then x squared plus y squared equals 16. No longer are there t's in there. Does anybody know what shape is this? It's a circle with radius what? You're close. 4. Yep. This side is r squared. Okay? So, yeah, that would be your final answer. You've gotten rid of t. This is how we would write a circle, right? X squared plus y squared equals r squared. Yep, it would be just like that. So we got to remember our rules from last check or 2? Oh, just that one. What did I tell you when we first talked about that rule? I thought it was minus. No. Cosine squared plus sine squared is 1, and we'll use it like forever and ever. Okay? All right. Do you guys need to see another example of this, or are we good? We're good? All right. I got a little bit more to talk about, dude. Yeah, got a little bit more. Not much more, but a little bit more. All right, so everything we've done so far is taking it from parametric and changing it into ours. But what if we have it as ours and we want to make it parametric? Okay, so now we got to talk about changing from coordinate to parametric. If it is a line segment, that's the one I would like to start with first. A line segment. It is going to follow this super easy formula. Whoops. It is going to follow x equals x1 plus at and y equals y1 plus bt. That's the formula we're going to use. So let me show you how this works. If I give you 2 points, so let's say Our first point, we're going to use the point negative 2, 3. And our second point is 3, 6. So this is going, it's a line segment between these 2 points. Okay? Everybody can picture that? Line segment between those. So we are going to write it as a parametric equation. First thing we do is we are going to use our x1 and y1 in our equations. We are going to use 3 and 6 as our x and y. All right? And we're going to solve for a. Okay? So, first thing, our x1, this is our x1, y1 over here. So, I have x equals negative 2 plus at. I want you to kind of think of that for a minute. Which means I'm also going to do y equals 3 plus bt. All right, so when you are putting in a line segment, we go in segments of 1 unit, right? I want you to plug that in for t. T is going to be 1. And again, we're going to use our second point as our x and y to solve for t. So solve for a and b. Use t equals 1 and xy to find a and b. All right, so in the first one, I have 3 equals negative 2 plus a, which means my a value is going to be 5. All right. In the second one, I can move this down a little bit. I've got this one. I'm going to plug in 6 for y, so I have 6 equals 3 plus b, which means b equals 3. So here are our 2 equations. First one is x equals negative 2. We said a is 5, and then you keep your t in there. Second equation, y equals, again, we have our y1 as 3, plus our b is 3, with our t. What do you think? We're okay? All right, it just follows the same idea, and there's only a couple of those you have to do. And let's leave off 31, because I didn't get a chance to get to that. We only have a couple minutes. So do you guys have a question on this one? Do you want another example of this one? Do you want... Okay, I just want to make sure. All right, so since you still have a couple minutes, it's perfect to open up that book, do the first couple, graphing it on your graphing calculator in parametric so you can pick out your graph. Yeah, 1 through 29 odd. We'll just leave off the last one because I didn't get a chance to get to it, okay? We'll cover it tomorrow. I just don't like to give you something that we don't